to be talking about how to solve rational equations. Now, the word equations indicates that there's an equal sign in the equation, basically. And so that means that your answer is going to have to be x is equal to some number. So when you have an equation, you have to solve it for x. And the problem with these equations is that x is stuck under the radical somewhere. So trying to isolate x, you can't just add something or subtract something or divide something. You have to actually do more to get the x isolated. All right, so let's look at the steps. So the steps are to isolate the radical on one side if you can. Raise both sides to the nth exponent. In other words, you're going to square both sides or cube both sides or something to that effect so that you can get rid of the radical. The only way to get the radical out of the equation is to do the opposite or the inverse. Since this is a square root in this case, you have to square both sides. If it were a cube root, you would cube both sides. Again, whatever you do the left, you have to do the right. Then you're just going to solve for the variable like normal. And then you'll have to check your answer back in the original equation that you were given in the very beginning. Now, the reason for that is because you might have what's called extraneous solutions. These are solutions where you solve for x, you get a number, you did everything right, but that number, when you plug it back in, doesn't actually work. So there's no way x can be a number and this side not equal to that side. So it's called an extraneous solution because you solved it, but the problem is it's extraneous. It doesn't actually work. So in that case, you would write no solution. So if the value that you solved for doesn't work in the original equation, you don't get to keep it. So let's look at a couple of examples. So this one right here, you have a square root on the left, so it's already isolated, and you've got some numbers or a number on the right, and you want to solve for x. Okay, that's our whole goal in life, it seems like. All right, so it's already isolated, so you just square both sides. That's the second step. So when you square the left and square the right, the left side, when you square root something and you square something, it's the inverse of each other, so you end up getting the same number that you had before. You can think of it this way too. The squaring this, that means this times itself. When you're looking for two sets of something, you end up getting two sets of the same thing. And so it cancels. All right, so you can pull the 2x plus 3 out. You get 25. Now you just solve it like normal. You subtract, you divide, you do what you need to do to isolate x. Now that I think x is equal to 11, I have to check it back with the original equation. And again, the reason I have to put it back in the original equation is because it could be an extraneous solution. So in this case, I go back to the original equation. I put 11 where x was, and I check. And I have question marks here on purpose because I don't know if 11 is going to work. We think it is. So when you solve it, you end up getting 5 on the left. Is that really equal to 5 on the right? Yes. Since the left and right are equal to each other, x is equal to 11, which is what I originally solved for, is an actual solution. So you get to keep it. Let's do another one. These are different, so make sure you watch to the end. All right, so here's a radical equation. What's the problem here? Well, the problem is that this equation doesn't have the radical all isolated on the left-hand side and only a number on the right. There's that -8 in the way. So in order to get -8 out of the way, I have to add 8 to both sides. Now I have the radical by itself and then everything else on the other side. Once I've isolated the radical, since it's a square root, I'm going to square both sides. Once I square both sides, I just solve it like a regular equation. Isolate to get x. Now I do have to do the check to make sure it's not an extraneous solution. So I put 17 everywhere there was an x in the original equation. And then I say, is that really equal? Is the left side going to equal the right side? Because if the left side doesn't equal the right side, well then I have an extraneous solution. In this case, they turn out to be the same. So my answer is x is equal to 17. All right, heads up, this next one's going to have an extraneous solution. So here we go. We don't have the radical isolated, so we got to get rid of the 10. So it's being added, so we subtract it from both sides. Whatever I do to the left, I have to do the right. I get a radical on the left, so that's good. Now, what I notice here right off the bat, before I go any further, is that I have that the square root of a number is equal to a negative number. That's not possible unless you're working with imaginary numbers. I already know at this point that there's no solution to this, but I'm going to go ahead and work it out because you might not notice when you're doing this. So we're going to go ahead and square both sides like you normally would, solve for x like you normally would, and then you go over and you check it. Let's assume that I didn't know that this wasn't going to have a solution. So you go ahead and put the 2/3 everywhere there was an x, and you check to say, hey, is the left side of my equation going to equal the right? So I evaluate everything, and guess what? I get 13 is equal to 4. Well, 13 is clearly not equal to 4. So I said, no, it's not. So since the left and the right are not equal, I'm going to say there's no solution here, right? I can also say that there's an empty set. An empty set is another way of saying there is no number that there's a solution. It's empty. It kind of looks like this, but please don't make it look like a 0 because it's not a 0. X is not 0. It means that there are no values of x that make this equation true, at least not real values. All right, so let's do another one. What if you have this? Kind of crazy. You have radicals on both sides of the equation. Now remember, step 1 was to isolate the radical on one side of the equation if possible. Well, in this case, we can't just put one radical on one side. We've got two radicals. If we tried to subtract this guy, now we just have two radicals subtracted. That doesn't help us. But actually, this equation is not so bad because to solve getting rid of the radical on the left-hand side, you would square it. And if you squared the right-hand side also, which you have to do, whatever you do the left, you have to do the right, it turns out it gets rid of this radical and that radical. So actually, you're not in bad shape. As long as there's no extra numbers floating around, like adding or subtracting other numbers, it becomes more complicated, but in this case, not so bad. So you're going to follow the same step as if you would. You square the left, square the right. Both of them get rid of their radicals. You solve for x. The only difference here is you've got x's on both sides. You got to combine your x terms and then combine your constants. I think x is 1. I'm going to check it out. So I go over here, and remember, I'm going to have to put x in, or excuse me, I'm going to put 1 in everywhere there's an x. And since there happens to be an x on both sides, I have to put a 1 on both sides whenever I'm checking it. So I evaluate the left, I get square root of 8. I evaluate the right, I get square root of 8. Square root of 8 is equal to square root of 8. So that checks out. So x is equal to 1 is an actual solution. All right, I want you to pause the video and try these. Okay. Here are the worked out solutions for those two problems. Hopefully your answers look like these answers. Good luck. Remember your steps, and I'll see you next time.